Hello and welcome to this Dr. Frost video on converting numbers to decimal from any base greater than 10. And the question is, we want to convert the hexadecimal number C47, and this little 16 here means the base of the number, so it's base 16, which is also known as hexadecimal. So hexadecimal means base 16. I'll remind you what base means in a second, and we're going to convert that to a decimal. And a decimal is just a normal number. So all our numbers in decimal form. So numbers that we use in everyday life, they are normal numbers, and they're in base 10. And as I said, I'll explain what base is as a reminder, even though I covered it in previous videos. Now, what the base of a number means is the number of possible values for each digit. So for example, if I'm working with a normal number, base 10, well, each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 possible values for each digit, and therefore it's base 10, our normal number system. Or take binary. Binary, each digit can be 0 or 1, so like 10110, that's a binary number. Each digit can either be 0 or 1. That's two possible values, so binary is base 2. And let me just do an example with binary, and that will help us with this question. Let's just say I had 1011 as a binary number. I like to put it in a box. And binary is in base 2. I'm going to put a little 2 here to mean it's base 2. It's not part of the number, it just means we're in base 2. Just like here, the C47, I put a little 16 to say that we're in base 16, because otherwise it might not be clear what base we're in. If I read 1011, I might mean 1011 if it's a normal number, but I don't. I mean 1011 in binary. And do you remember that the rightmost digit in any number system is always the units digit. So above my box, I'm always going to put a 1 at the right to say this digit is the units digit, it's worth 1. But remember, if it's base 2, then each digit as you go from right to left is worth twice as much because it's base 2. That's the base there. 1 times 2 is 2. So this digit is the 2's digit, times by 2 again. This digit is the 4's digit, and this digit here is the 8's digit. And then, okay, we've got 1 here which is worth 8, so 1 times 8 is 8. We've got 0 here which is worth 4, 0 times 4 is just 0. We've got 1 here which is worth 2, so 1 times 2 is 2, 1 times 1 is 1, and 8 plus 2 plus 1 is 11. So as a normal number, 1011 means 11. It has the same value as 11 in the way we'd normally interpret 11. So what we're going to do here, we've got C47, so I'm going to put this in a box, so C47. Now, this is a bit weird because we've got a number here with a letter in it. What on earth does that C mean? Well, the problem is that once we get past 9, we don't have a way of representing digits that just use a single symbol. Because after 9 comes 10, but that uses 2 digits, but we want to have 1 digit at a time. And because it's base 16, we have to have 16 possible values for each digit, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's only 10 possible values. So we have to create some extra symbols, and we're going to use A, B, C, D, E, F, to mean a value above 10. So we have 0 to 9, so 0, 1, 2, 3, 4, 5, up to 9. And then after 9, it goes A, so A is worth 10, and then it goes B, so it's worth 11, C is 12, D is 13, etc., all the way up to F, which is 15, and that's the highest you can go in hexadecimal. So this C is actually worth 12, so I'm going to cross out this C and put a 12 to say that the C is worth 12. Now, we do the same as we did before. We have the units digit, so the value of this digit is the units digit is worth 1. And because it's base 16, each time we go from right to left, the digit is worth 16 times as much. 1 times 16 is 16. 16 times 16 is 256. And then we do what we did before. Each of those 12s here is worth 256. So we times these together. So I'm going to do that on a calculator because I can't be able to do it in my head. So that's 3072. Now these 4s here are each worth 16. 4 times 16 is 64. And then we've got 7 times 1, which is 7. And if I add those up, 3072 plus 64 plus 7 is 3143. So the hexadecimal number C47 has a value of 3,143 as a normal number, as a decimal number in base 10. And if you forget what A, B, C, D or E means, etc., then just write a little table here. So A is always worth 10, A is the first digit after 9, and then it goes up by 1 each time.